With its fancy timeout and window calculations, TCP is a great transport for most applications. But it's not perfect, and depending on the application, there are ways that you can do better. And one particular application is important. That's the case of web services. To point out one problem, TCP is working over IP, and these connections depend on the address of both ends of the connection. But if you're working from your phone, say, and you go from the classroom out to your car, then you're probably going from the Wi-Fi network and switching over to a mobile phone network. And since your phone is switching to a different network, it will have a different address, probably going through a different interface at the operating system level. And since you have a new address now, you have to create a new connection to the server, even if you are in the process of using some web service as you move from the classroom to the car. So that means a new connection, and that means starting all over with slow start and so on to get that data flowing. Another problem is that a typical web page, say, needs multiple files. It needs the base HTML plus some styling through CSS and probably some pictures and probably some other pictures. And those, if you just ask for them one at a time, means that you don't start getting a picture until you've got the whole web page. But those pieces may come from different places, and it might be better to do them all at the same time. So getting the HTML part first can delay the whole page, whereas maybe if you get a little bit of the HTML plus an image, you could start rendering the page. So we want to do better than getting them all in order. Even worse than that, what if the HTML page gets going pretty well but then stalls? A dropped packet will send us into slow starts and other recoveries that will mean we have to wait even longer for that other data. Now, HTTP2, which has been in place for quite a while, improves on this situation by allowing a single connection to ask for multiple things and have those results be interleaved in the response. So the client could request the HTML and some images and styling all at once, and as it flows in, the browser knows how to deal with pieces of that data coming in, and so it can get started rendering the web page early. That solves part of the problem, but we still have the problem that when a packet goes wrong, say for the HTML, then because this is all over one TCP connection, even if we got some packets successfully delivered for an image or the styling, we can't use them yet. The application doesn't see them. The OS is still trying to recover and get this missing packet before it moves on to the other data. So this is called the head of line problem, and it's various forms. It means, if something is supposed to come in first, we have to wait for that thing before we can go get the other things. You could avoid this problem by making multiple TCP connections. Each of them will be independent, and so if a packet gets lost here in the HTML stream, it doesn't affect these totally separate TCP connections that we're getting CSS and files, say. But the problem with doing 4 connections is you have to do 4 times the startup. And remember, getting set up means that the client has to send a send packet to the server, and the server has to respond before we can actually start sending data. And so we multiply this overhead by n if we create n different connections. And actually, it's a little worse than that TCP setup because in the modern web, everything is also encrypted. And it turns out that there is this process, the encoding TLS. There's a similar sort of handshake process between the client and server to get started with encryption. We will talk more about those details later in the semester, but the point to realize now is that you would have to do that encryption setup also for every separate piece of data. And this is sometimes called handshake hell because we just keep having to set up layers of different things. We're having to do the overhead of that setup in every separate connection. Now, if you want to improve over TCP, another problem is just that, TCP is an old and established protocol, and while it's sitting at the transport layer, which we've talked about as being at the operating system level, we're going to see how the lines get a little bit blurred as you go out over the network. And in fact, routers, while nominally they're at the network layer and are only paying attention to IP information, they actually end up looking at TCP information as well. So these transport layer protocols get embedded in the hardware that's sitting all over the network. And you can't just replace TCP with something else without breaking all of that hardware and actually having to reinstall physical things, which is much harder. So this is a notion of ossification, the idea that the standard that is in place gets even more ingrained into the system over time and becomes harder to change.